Hi, this is Zhuo Chen. So this app is a double pendulum simulator. Everyone here knows what a pendulum looks like, right? So a double pendulum is just two pendulums being connected together. The double pendulum we simulated consists of two point masses and two hard rods and being attached to some point. As you can see, here are some examples of a double pendulum and their traces. So we choose to do this double pendulum simply because it is quite interesting. The double pendulum is known to be chaotic or has chaotic behavior, which could be explained as a tiny difference in the input will result in a huge difference in output. Examples of chaotic behaviors include weather and climate, which is why it is so hard to forecast, and the road traffic. Most importantly, it is not hard for me to implement since I'm a physics major student. And now let my partner to introduce you how to use this app.
Okay, so this app, as you can see, receives a total of 8 different inputs from the user, which are the mass of two objects, the length of two rods, and their initial angles and speed. And they also have default values if you don't enter value, and there are also several other built-in variables, which are the gravitational acceleration and the time interval of our simulation. And what will be displayed here is the horizontal position versus time and the vertical position versus time graph of the second object, the, the object that is further from the attached point. Um, as you can see here with our default values, the graph looks like this. And obviously, the mass and length cannot be zero. So if you enter zero, the app will tell you that you entered invalid parameters. Okay, let's play around with it. So let to let first mass to be 5, second to be 10. Oh, it's a bit slow. All right, and okay, our first length to be about 2.3, and our second length to be 6. Yeah, actually, I don't know what's going on here. Yeah, I don't know what's going on, but it looks good. And what I'm going to show you next is about how tiny differences in inputs will result in very divergent results. So let's clean it for a while. And remember that our initial value for length is 1 meters, and if I change it to just 1.1, still a bit slow. And yeah, as you can see here, um, at the very beginning, the graph still looks quite similar, but as it continues to move, it's just the graph just looks very different. There's huge difference between them, which is a chaotic behavior. Yeah. So originally, the idea is to display 2 points moving in a XY coordinate, just like was shown on the Wikipedia. But the display code we found on the internet does a really poor job at drawing the orbit. So the horizontal coordinate must increase in value, otherwise the app will crash. So instead, we move to just place ST and YT graph.
Okay, so let me talk more about this. So initially, I implemented this double pendulum in Java because I didn't expect the final project to be an Android project. But my partner did a great job in transferring the code from Java to this Android project. And initially, we are using a method to solve the differential equation called Euler's method, which is just approximate the curve using several straight lines. And as you can see here, the error is quite huge, and actually it's proportional to the third term of a Taylor polynomial. But afterwards, we use a better algorithm, which has a very smaller error, and we did a lot of calculation. It's hard to implement, but we did a great job of implementing this method. and we reduce the error, and actually we can reduce the iteration we need, so we can have a faster run speed of this application. That's all. Thank you.